Okay, class, I'm just going to show you, hopefully it'll be short, animation of the flow of CSF, because that is kind of hard to visualize. And so I wanted to give a shout out to Tad for making this. I think it really helps the students visualize what is going on with this flow. So let me just kind of explain this little diagram. Obviously a lateral view. So this big blue structure up on the top is the superior sagittal sinus, one of your dural venous sinuses that we went over in detail. Here is your transverse sinus. You can visualize that coming out this way. Here is the sigmoid sinus. Now the sigmoid sinus, it will be carrying all this deoxygenated, used up venous blood from the brain. It will leave through there's an opening in the cranium called the jugular foramen, remember? And this is now the internal jugular vein. The internal jugular vein takes all that used up venous blood back to the right heart. In the lime green here, this lime green is showing you the subarachnoid space. So the subarachnoid space, remember, is around the entire CNS, around the brain, and around the spinal cord. So just remember that. Subarachnoid space, that is where our CSF will be flowing. So I'm going to remove part of this venous system so we can get a better look at our ventricles. So now let's go through the ventricles. If you have your worksheet out that I had for you, you can follow along because it might be easier to see. But remember, this is a lateral view, so we're only seeing one of our lateral ventricles. There's a lateral ventricle in each of our cerebral hemispheres. So let me outline this lateral ventricle for you. Here's the front, and then we're going to go to the back side, and up here. This whole thing is the lateral ventricle. Here is the choroid plexus of the lateral ventricle. Remember, this is where CSF is made. These are capillaries, and with the help of our ependymal cells, we are creating CSF. Here is our third ventricle, right here. This is the choroid plexus of the third ventricle. This area of the third ventricle, where the third ventricle is, this is the area of the diencephalon in your brain. This is a midline structure, and we'll talk about it soon. This is where you're going to have your epithalamus, your thalamus, and your hypothalamus. So the area of the third diencephalon is where the third ventricle is. The third ventricle is connected to this structure called the cerebral aqueduct. This is going to be in the area of the midbrain. The cerebral aqueduct is now connected to this structure, the fourth ventricle. So this fourth ventricle has its choroid plexus also. So remember, CSF is made in all four ventricles. Once we get to this fourth ventricle, that is where we're going to have CSF leave our ventricular system. The CSF is going to leave through two lateral apertures. You cannot see it here, but it's on your worksheet. So look for those lateral apertures. The two lateral apertures are going to take CSF into the subarachnoid space, and we have one median aperture that is going to be taking CSF from the fourth ventricle and delivering it into this area underneath the cerebellum. And we're going to have a continuation of the CSF. It's going to be flowing into the central canal of the spinal cord. So we're leaving the fourth ventricle into the subarachnoid space by 2 lateral apertures and 1 median aperture. So remember that. So let's see what the flow is going to look like. There it is, going into the lateral ventricles, third ventricle. Now we're going down into the cerebral aqueduct, fourth ventricle, and this is showing you going straight down into the central canal. But at the same time that is happening, it would also be leaving the 2 lateral apertures and the median aperture, which is going to show you shortly, going into that subarachnoid space. So CSF going into that subarachnoid space, all around the brain and all around the spinal cord. Very important. So now we have the CSF in our subarachnoid space. So here we have our CSF. Why is that important? Why am I talking about this so much? I want you to understand that, number one, you know CSF is made in the ventricles, right? And it leaves the ventricles, the ventricular system, through the fourth ventricle that's taking it into the subarachnoid space and down into the central canal of the spinal cord. So, what happens in the brain, whatever's happening up in the brain in the CSF, you're going to find that down in the spinal cord. So if you do a lumbar puncture, which you are taking CSF from areas L3, L4, L5, that CSF from the that lumbar puncture that you're taking, you are actually having a view of what is going on up in the brain. So that's going to be important clinically. Also important clinically is if you have some kind of obstruction to the flow of the CSF out of the ventricles, that can cause a backup of CSF. And that, if you have an obstruction, that can be that will cause hydrocephalus. Hydrocephalus just means water on the brain. There is too much CSF. It's not being allowed to leave properly. So you're going to get a backup of CSF. Now, also, these ventricles are making CSF continuously. They are making around 20 cc's an hour, so that will come out roughly about 500 cc's per day. Continuous production of CSF, fresh CSF. But at any one time, there's only going to be about 125, 150 cc's in the system. So where's all that extra CSF going? Well, here's the CSF. When the CSF pressure gets built up, it's going to be leaving through these arachnoid granulations in the superior that are sticking into the superior sagittal sinus. So I'll show you a close-up picture of this. But these arachnoid granulations, think of them as one-way valves. They're leaving the subarachnoid space where the CSF is, and they're going to be dumping that CSF into the superior sagittal sinus. So that's used up CSF is being dumped back into the superior sagittal sinus, and of course it will all eventually be taken back to the right heart. No big deal, because where did we make CSF? We made it from the capillaries. We made it from the capillaries, the blood that is within these ventricles. So we make CSF from blood, and CSF is going to be dumped back into blood. No big deal. So I just wanted to add this little end bit to the flow of CSF just to clarify anything. if you guys had any clarification needed, here is a drawing of a choroid plexus. So remember you heard the word plexus when we're doing the spinal nerve plexuses? A plexus is just a network. It's a tangled mess. And I will show you that on the next picture, what these look like. But here's a drawing. This is a capillary. Remember, simple squamous. And these choroid plexuses are going to be lined with ependymal cells. And these ependymal cells are playing an important part in filtering what comes out into the CSF. So here we have our blood is in these capillaries. They're going to create what they call a filtrate. They're filtering stuff out of the blood, and it's processed through these ependymal cells that are interfacing these capillaries. What is coming out? What is being made? Stuff that the neurons want and need. Oxygen, vitamins, certain ions, sodium chloride, magnesium, glucose, all this stuff that is going to be helping the neurons. There will be no cells coming out, no red blood cells, no white blood cells, no proteins either. This is a clear fluid. It's like gold for the neurons. And these ependymal cells, some of them have microvilli. They are actually going to be absorbing any waste products from the neurons, and they're going to absorb it back into the capillaries. So good stuff, the CSF. Hopefully that clarified that a little bit. This is what they look like. These are in the lateral ventricles. If we did a sheep brain dissection, you would actually see these. These are little tufts. They are tangled messes, and that's why they call them a plexus. And then I just wanted to include hydrocephalus, what happens when you have a blockage of CSF flow. And this is usually going to happen in the ventricular system, and you get these large craniums. So in a baby, a little child, the brain can expand like this because the bones of the cranium, the cranial bones have not been fused together. So that's why you can get expansion in a child. Not so much in an adult, but in a child, those skull bones have not fused together yet. It's going to be treated by a shunt, they call it a ventriculoperitoneal shunt, going from the ventricles into the peritoneum. Usually they're going to drill a hole in the skull and put that tube in the lateral ventricles, and it's going to come out in the skin. It's going to travel behind the ear, down the neck and the chest. It's just underneath the skin, and they're going to place it to drain into the peritoneal cavity. Kind of cool. So I just wanted to do a total recap of CSF circulation, make sure you guys understand it. And mostly I wanted to show you these arachnoid granulations. You saw earlier that these arachnoid granulations, aka arachnoid villi, are projecting into the superior sagittal sinus. And these arachnoid granulations, here's a close-up. So this is part of the arachnoid. But in the subarachnoid space, we have our CSF flowing. So these arachnoid granulations are acting like one-way valves. We are making CSF on a continuous basis, so we're going to have to remove some of the older CSF, and we are dumping it into the superior sagittal sinus. So these one-way valves dumping CSF into the superior sagittal sinus. Those are the arachnoid villi, aka arachnoid granulations. Let's do a quick recap of the CSF flow that you need to know. We are going to start in our two lateral ventricles, right and left. lateral ventricles. We're going to leave through the interventricular foramen, down into the third ventricle, down through the cerebral aqueduct, which is going to take us to our fourth ventricle. At the fourth ventricle, we can either continue down into the central canal of the spinal cord, or we're going to be leaving the fourth ventricle through our two lateral apertures. They don't show it here either. It's a little hole here they're showing, and the median aperture. They're going to take that CSF into our subarachnoid spaces, and those subarachnoid spaces are going to flow around the spinal cord and the brain, and then we're going to return that used up CSF back through these arachnoid granulations and dump that CSF into the superior sagittal sinus. So here is the flow that you must know. We're going to start with our right and left lateral ventricles, go into the interventricular foramen, which will take us to the third ventricle. Then we're going to leave the third ventricle into the cerebral aqueduct, which will take us to the fourth ventricle. And in the fourth ventricle, we can either leave the ventricular system through that central canal of the spinal cord, or go into our subarachnoid space via our two lateral apertures and our one median aperture. So we're going to, in that subarachnoid space, we're going to leave that subarachnoid space via our arachnoid granulations or arachnoid villi, which are projecting into our superior sagittal sinus. And so they're dumping that CSF into the superior sagittal sinus. From the superior sagittal sinus, we're going to go into our right and left transverse sinuses, our right and left sigmoid sinuses, into our right and left internal jugular veins, and then into our right and left brachiocephalic veins, into the superior vena cava, and back to our right atrium. This is not that hard. You just need to follow it along with your diagrams and figure out where you are. It will make total sense. So hopefully that helped you visualize this a little bit better. I hope. That's my hope.